Is quantum computing a threat to Bitcoin? Many people believe that as quantum computing advances, Bitcoin and its cryptography will be destroyed. What exactly is quantum computing? Could it break Bitcoin's cryptography? A quantum computer uses quantum mechanics to process information. Unlike classical computers, which use bits that are either 0 or 1, quantum computers use qubits, which can exist in a superposition, a blend of both 0 and 1 at the same time, with certain probabilities. These quantum properties allow for massively parallel computation, giving quantum computers the potential to solve certain problems much faster than classical ones. It threatens elliptic curve digital signature algorithm used to sign transactions, and SHA-256 used to secure Bitcoin mining and addresses. This would require around 1,500 logical qubits, or millions of physical qubits, and we are nowhere near that level. Quantum computing could also break other cryptographic systems like nuclear codes, banking, or the internet. The key difference is that those systems can be rebuilt or upgraded to new, quantum-resistant standards. With Bitcoin, however, once its cryptography is broken, it is way more difficult to reverse the damage. To solve the problem of cryptographic breakage with quantum computing in Bitcoin, we have two options: through a soft fork or through a hard fork. In the case of using a soft fork, we need to know that currently, only old addresses are affected, those that expose the public key directly on the blockchain. A quantum computer could potentially derive the private key from the public key using Shor's algorithm. New addresses could also be at risk if they are reused, as that would expose part of the elliptic curve. For new addresses, from SegWit onwards, the situation is different. If you've received Bitcoin to one of these addresses but haven't spent it or reused the address, the public key isn't directly exposed on the blockchain. Instead, only a hash of the public key is stored, making it much harder for a quantum computer to obtain the private key. BEP360 could serve as a transitional solution. It uses post-quantum cryptography and doesn't require a hard fork or an increase in block size. It would allow for a gradual transition to quantum-resistant systems while remaining fully compatible with the existing Bitcoin protocol. A hard fork would be the other solution to make Bitcoin quantum-resistant by replacing current cryptography with quantum-safe algorithms, such as lattice-based cryptography. This would ensure Bitcoin's security for decades. While a hard fork would offer long-term protection, it would require widespread consensus, testing, and could introduce compatibility issues or increased computational costs. Developing quantum cryptography capable of breaking Bitcoin's current encryption would lead to a significant reward or honeypot. The first thing that comes to mind is Satoshi's Bitcoin, which is estimated to be over 1 million coins. Fortunately, these coins are spread across thousands of wallets, with 50 BTC in each. This means that if the cryptography were broken, it wouldn't lead to a direct dump of 1 million BTC onto the market all at once. Therefore, the biggest honeypot in the Bitcoin ecosystem would likely be the wallets of large exchanges such as Kraken and Binance, where massive amounts of Bitcoin are held. If Bitcoin's cryptography were compromised, these large exchange wallets would be exposed to a significant risk. This will likely affect the price, but it should recover once a solution is implemented. It's important to note that the hash rate continues to hit all-time highs, and many individuals, companies, and entities are invested in ensuring Bitcoin remains functional. These parties would likely collaborate to develop a solution that ensures Bitcoin remains a neutral currency for the future. Then, could quantum computers kill Bitcoin? Considering how Bitcoin is growing larger and reaching more places, and that more and more people are invested in finding a solution, it seems unlikely. Quantum-resistant cryptography must be developed not only for Bitcoin, but for many other sectors as well, so that there are strong incentives to make it work. Bitcoin is like a black hole, gradually consuming fiat currency, and it will likely continue to do so. Even if quantum computing breaks the current cryptography, what alternative would we have? In the best-case scenario, we'd return to commodities like gold, which are still susceptible to manipulation. Or we could stick to fiat money, which constantly devalues and extracts the value of our work and effort through inflation and centralization. With Bitcoin, we've already won the most important battle, the mental battle. We've realized that a silent revolution is needed to create a neutral currency that doesn't steal from the value of our labor. The idea of a decentralized, transparent, and trustless monetary system is already a powerful concept in people's minds. Bitcoin has demonstrated the possibility of this new system, and regardless of the challenges, the momentum towards a better alternative to fiat is unstoppable.